A very good day to Enchik Zulafik, our engineering mathematics lecturer. Today we are going to present our PBL report. Also, we would not to forget to express our thanks to Enchik Zulafik, our engineering mathematics lecturer, guidance in completing this project. As shown on the slide, these are the group members, which consist of me, Richard, Pevitaraj, Durges, Dara, and Scott. That's all. Okay, now for the introduction. Newton's law of cooling is a physical law which states the rate of heat loss of a body is directly proportional to the difference in temperatures between the body and its environment. The law is frequently qualified to include the condition that the temperature difference is small, and the nature of heat transfer mechanism remains the same. The statement of Newton's law used in the heat transfer literature puts into mathematics the idea that the rate of heat loss of a body is proportional to the difference in temperatures between the bodies and its surroundings. For a temperature-independent heat transfer coefficient, the statement is as shown on the slide. The temperature difference between the body and the environment decays exponentially as a function of time. Okay, now we move to radioactive decay. The mathematics of radioactive decay depends on a key assumption that the nucleus of a radionuclide has no memory or way of translating its history into its present behavior. A nucleus does not age with the passage of time, thus the probability of its breaking down does not increase with time but stay constant. No matter how long the nucleus has existed. Given a sample of a particular radioisotope, the number of decay events, difference in n, expected to occur in a small interval of time. Difference in time is proportional to the numbers of atoms present n. That is shown in slide. The expected decay, negative difference in n over n is proportional to an increment of time dt. The solution to this first order differential equation is the function of as shown in slide. Thank you. Okay, now for the problem statement. For question 2 part A, this is the problem background. During the holiday season, you assisted your auntie with a catering business where you were tasked with cooling down hot soup before serving it to guests. The cooling rate of the soup is proportional to the room temperature, and it was observed that a container of soup placed in a room at 18 degrees Celsius cooled from 82 degrees Celsius to 50 degrees Celsius in 6 minutes, prompting the need to determine the length of time required for the soup to cool further from 30 degrees Celsius to 22 degrees Celsius. To determine the length of time required for the soup to cool from 30 degrees Celsius to 22 degrees Celsius, the following must be carried out. Okay, first of all, we need to prove the solution is a separable equation. And then we need to find the value of k. And lastly, we need to determine the time taken for the solution to cool from 30 degrees Celsius to 22 degrees Celsius. And then for part B, question 3, this is the problem background. Hydrocodone bitatrate used as a cough suppressant decreases in quantity in the body at the rate proportional to the amount remaining after full absorption, given that the amount of the drug left in the body is half from the original dose of 10 mg after 3.8 hours. The problem requires determining the amount remaining after 12 hours. The step is as follows. First of all, we need to prove the solution is a separable equation. And then, what is the value of k? We need to find the value of k. And then lastly, we need to determine the amount of hydrocodone bitatrate left in the body after 12 hours. That's it.
Hello, my name is Durgeshwaran. In this video, I'll explain about the Fila table. For part A, question 2, there's 3 facts. First one is the temperature of the hot soup when placed in a room temperature is 82 Celsius, then cooled to 52 Celsius. For these facts, the ideal is find the value of k. Actions. What is the value of k referred to the hot soup after 6 minutes? Learning outcome is to calculate the value of k by referring the temperature of hot soup after 6 minutes. Fact number 2. The time taken for the hot soup to reach 22 Celsius from 30 Celsius. The ideal is to use the Newton's law of cooling formula. Action is what is the time taken for the hot soup to reach final temperature of 22 Celsius. Learning outcome is to calculate the time taken by referring to the constant room temperature and value of K. The final fact is room temperature is constant, that is 18 Celsius. Ideal is how many minutes is the hot soup is left down to cool. Action is to understand the information from the questions, and the learning outcome is by referring to the question 2 to get the value. For part B, question 3, there's 3 facts also. Fact number 1 is, after 3.8 hours, the amount of hydrocodone bitartrate left in the body is half of the original dose taken. The idea is to use radioactive decay formula. And the action is what is the coefficient of drug decay R. Learning outcome is to calculate the coefficient of drug decay in the body after 3.8 hours by using the formula. Second fact is the amount of drug left after 12 hours. Idea is to use the radioactive decay formula again, and the action is to understand to use the coefficient of drug R in the formula. Learning outcome is to use the coefficient of drug decay and find the amount of drug left in the body. The final fact is hydrocodone bitartrate left in the body is half of the original dose taken, which is 10 mg. The ideal is the amount of drug left in the body after 3.8 hours. The action is to understand to get the information from the question, and learning outcomes is get by referring to the question number 3.
Hello, my name is Darrell Enric, and right now I will present the solution part. So the solution part consists of 2 parts, part A and part B. Part A related to Newton's law of cooling, and part B is radioactive decay. So part A, question A, they ask us about whether the equation can be separable or not. So they have given us T temperature over D time equals to negative K multiplied by T minus T room temperature. So what we're going to do is we're going to bring the temperature to one side, the formula that has temperature to one side, and the rest on the other side. So we will get here 1 over temperature minus room temperature dt equals to negative K D time. So right here we can do integration, and after integration we'll finalize the formula. We'll get the answer T minus T environment, which is room temperature, equals to e power of negative KT plus C. So right here there is an issue because we have 2 constant, one is K and one is C. So we cannot have 2 constant in one formula. So because if we have 2 constant, we cannot find the answer. So what we're going to do is we'll take EC, we'll sub it to A, new unknown. Okay, so A equals to e power of C, and then we can sub back to the formula T minus TE equals to A multiplied by E power of negative KT. And once we get everything, so we still have 2 unknown, one is K, one is A, so we will sub 0 into T. That means when T equals to 0, the cooling process begins, and the temperature at T is equals to 0, which means it's the initial temperature. So we submit the formula, we will get T initial equals to TE plus AE power of negative K multiplied by 0. So E power of 0 equals to 1, and then we can get 1 multiplied by A equals to A. So we'll get the answer T initial equals to T environment plus A. So we can know that A equals to T initial multiplied by T initial minus by T environment. So once we get this, we can sub back to the original formula that we get earlier, and then we will get T time equals to T environment plus T initial minus T environment multiplied by E power of negative KT. That is the final formula. And right here for the question B and C, so question B, they ask us to find the value of K, the constant value. So what we can do, the question has already given us some value, so it's easier for us to calculate the value of K. They've given us environment temperature is 18 degrees Celsius, initial temperature of the soup is 82 degrees Celsius, and then temperature of the soup at T time equals to 50 degrees Celsius, and the T is 6 minutes, which means after 6 minutes the soup from 82 degrees Celsius has already become 50 degrees Celsius. So we got all this information, simple, we just sub into the formula and then we can calculate the value of k. So once we sub in every formula, we can see here the value of k equals to 0.116. And once we got the value of k, we can proceed to question C. Question C, they're given us T initial is 30 degrees Celsius and T time after certain minutes, the temperature already become 22 degrees Celsius and the environment temperature still remain the same, 18 degrees Celsius. So they ask us to calculate what is the time taken for the soup from 30 degrees Celsius to become 22 degrees Celsius. So we can sub into the formula as well as the value of k, and then we can get T time equals to 9.51 minutes. That means it takes 9.51 minutes to cool from 30 degrees Celsius to 22 degrees Celsius. Next up, part B, question A. Same as part A, question A. They ask us to calculate whether they ask us to prove whether the formula is separable equation or not. They've given us dn over dt equals to negative rn. N is the amount of the drugs, the drugs in the body, and t is time, and r is constant. So we're going to do the same thing. We're going to put n in the one side and then the rest in another side. So we'll get 1 over n dn equals to negative r dt. So same thing, we're going to do integration. Once you integrate everything, we will get the formula n equals to e power of negative rt multiplied by ec. So same as the part A, question A, we have two unknown, which is r and c. So same thing, a equals to e power of c, and then we sub into the formula, we will get n equals to a multiplied by e power of negative rt. And we are going to do the same thing because we have two unknown right here. So we'll sub 0 into t, and then we can calculate the value of a. So once we sub the 0 into t, we will get n initial equals to a multiplied by e power of negative r 0, and e power of 0 equals to 1, so a multiplied by 1 equals to a. So n initial equals to a, so we can sub back to the formula, n equals to ae power of negative rt, so the a will sub to n initial. So final answer we will get n at t time equals to n initial multiplied by e power of negative rt. So that is the final equation that we will use later. Let's move on to question B and question C. So question B, same thing, they ask us to find the constant, which is r. So they're given us at t equals to 0, the n at t time is 1, so which means n at t equals to 0, it's equals to 1. So we can sub into the formula we have found earlier, we have calculated earlier, which is the formula n at t time equals to n initial multiplied by e power of negative rt. So we can sub into the formula, we can calculate the value of n initial. So we'll get n initial equals to 1. So once we get n initial equals to 1, we can cancel off n initial because it's 1 multiplied by e is also e, so we can cancel off the n initial. And then the question also given us, after 3.8 hours, the amount left is half, which means after 3.8 hours, n equals to 0.5. So from here we can calculate the value of r. So what we'll do, we'll sub into the formula. So n at t time is 0.5, and then t is 3.8, so we can get r is 0.182. So once we got the value of r, we already got the value of n initial, so we can sub into the formula to find question C. So question C, they given us t time equals to 12, t is 12, but they never give us n, so they ask us to calculate n, which means after 12 hours, how much amount left of the drugs in the body? That is the question demand. So what we can do, we can simple n at t time, we just remain because we need to find that. So equals to e power of 0.182, 0.182, which is r, and multiplied by t. T is 12 hours. So we can get n at t time is 0.112. So after we get 0.112, the question has stated that the amount of drug left is half, and the amount of drug when is half is 10 milligram. So they ask us how many milligram left after 12 hours, so we can do comparison right here. So what I'm going to do is I'm going to put 0.5 over 0.112 equals to 10 over x. So we can calculate, and I can get that x equals to 2.24 milligram, which means after 12 hours the amount of drug left is 2.24 milligram.
Hello, my name is Paritra Singh. So I will be presenting about the conclusion of our project. So technically, in conclusion, we have successfully solved the problem that was given as our project together as a team, with each of us putting the work needed to get this project done successfully. Then for this project, we have applied differentiation formula or method or to solve the problem, and also we could also tell that we have applied the application of differentiation. And in part A, for question A, the equation was proved. Then following the part B, where the equation was proved in A, has to be applied or used in the part B. And also we have to substitute the value given to get the answer, which is K. And next, in part C, the K value that was found in B is used to substitute again in the part C, which is we have to substitute it in the equation, which is the Newton's law of cooling equation. Thus, after substituting all the values and the K in this equation, the K into the equation, and also we have substituted time that can be solved, which is 9.1 minutes. Which is given, or no, not given, which is solved by the my friend. And also, furthermore, whereas in part B, almost the same concept is applied as part A with different uh, formula, which is the radioactive decay. It's also a different situation or application, you could tell. Using this equation and after substituting the values in part B, the R could also be solved, which is 0.182, and same goes for part C, where the X can also be found, which is 2.24 milligrams. And that's all from me at the conclusion of this project. Thank you.
So, for the first meeting on the 24th June 2024, we all made a WhatsApp group where we all divided the task among all group members. So, for the second meeting, which is on 25th June, after class hour, we all gathered at campus UTHM outside Dewan Kuliah 2, where we discussed about the report and check every member work progress for the report. So, for the third meeting, which is the last meeting on 30th June, around 11 a.m. to 12 p.m. at College Kediaman UTHM or some other members that I already went back. This is where we finish up. We had a WhatsApp call meeting and finish up the report and send the report in the group to compile it. And we did a last checking before finalizing all the report, and we can finally start on our presentation and slide.